2 volumes of hydrogen react with 1 volume of oxygen to give 2 volumes of water. And when hydrogen and chlorine react, we have that hydrogen plus 1 mole of chlorine to give 2 moles of hydrogen chloride, or you say 1 volume of hydrogen react with 1 volume of chlorine to give 2 volumes of hydrogen chloride. Example 4. Find the volume of oxygen required to burn completely 30 cm³ of methane. Solution. Chemistry of reaction. Methane react with oxygen to give carbon dioxide and water. Therefore, by Avogadro's law, 1 volume of methane requires 2 volumes of oxygen. That is, 1 cm³ of methane requires 2 volumes of oxygen. Therefore, 30 cm³ methane requires 60 cm³ of oxygen. Example 5. Calculate the volume of oxygen required for complete combustion of 20 cm³ of ethane. Solution. Equation for the reaction. Ethane, 2 volumes of ethane react with 5 volumes of oxygen to give 4 volumes of carbon dioxide and 2 volumes of water. From the equation, 2 volumes of ethane requires 5 volumes of oxygen. That is, 2 cm³ of ethane requires 5 cm³ of oxygen. Therefore, 20 cm³ ethane requires 50 cm³ of oxygen. Note, it is important that the correct equation is written. Example 6. 20 cm³ of hydrogen were mixed with 100 cm³ of air containing 21% by volume of oxygen and explode. What was the composition and the volume of the residual gas if all the measurements were taken at STP? Solution. Since air contains 21% by volume of oxygen, 100 cm³ of air will contain 21 cm³ of oxygen and 79 cm³ of nitrogen. Equation for the reaction. Chemistry of the reaction. 2 volumes of water plus 1 volume of oxygen to give 2 volumes of water. Combining volume. 2 volumes of water react with 1 volume of oxygen to give 2 volumes of water. Before sparking, 20 cm³ of water react with 21 cm³ of oxygen, while the product volume was not given. After sparking, 20 cm³ of water react with 10 cm³ of oxygen to give 20 cm³ of water. Therefore, excess oxygen is 11 cm, that is 21 before sparking minus 10 after sparking. Therefore, the composition of the residual gases is equal to 11 cm³. The excess oxygen and 79 cm³ nitrogen will now be equal to 19 cm³. Vapor density. The vapor density of a gas or a vapor is the number of times a given volume of gas or vapor is heavier than the same volume of hydrogen measured and weighed under the same temperature and pressure. Vapor density Vd is equal to mass of 1 volume of a gas or vapor over mass of equal volume of hydrogen. Equation 1. Applying Avogadro's law, vapor density Vd for equation 2 is equal to mass of 1 molecule of a gas or a vapor divided by mass of molecule of hydrogen, which is equal to mass of 1 molecule of gas or vapor over mass of two atoms of hydrogen for the equation 3. Relative molecular mass for equation 4, we have that mass of one molecule of a gas vapor divided by mass of one atom of hydrogen. An examination of equation 3 and 4 shows that hydrogen is diatomic in the calculation of vapor density and monatomic in the calculation of relative molar mass. Therefore, relative molar mass is twice vapor density, that is, molar mass of gas equals to 2 times vapor density. The density of hydrogen at STP is 0.909 gram per dm cube. Example 7. Calculate the vapor densities of the following gases from the given data. 1. 560 cm cube of oxygen at STP weighs 0.8. 2. 1400 cm cube of sulfur 4 oxide weighs 4 gram. Solution. 1000 cm cube of hydrogen at STP weighs 0.09 gram. Therefore, 560 cm cube of hydrogen at STP weighs 560 over 1000 times 0.09, which will give us 0.05 grams. The vapor density is equal to mass of a given volume of gas over mass of equal volume of hydrogen, which equals to mass of 560 cm cube of oxygen divided by mass of 560 cm cube of hydrogen, which give us 0.8 over 0.05, which will give us 16, and vapor density does not have any units. Solution for the second question. 1000 cm cube of hydrogen at STP weighs 0.09 gram. Therefore, 1400 cm cube of hydrogen at STP weighs 560 divided by 1000 times 0.09, which give us 0.126. But vapor density is equal to mass of given volume of gas over mass of equal volume of hydrogen. Vapor density of sulfur tetraoxosulfate is now equal to mass of 1400 cm cube of tetraoxosulfate 6 divided by mass of 1400 cm cube of hydrogen, which will give us 4 over 0.126, which will now give us approximately 32. Example 8. An evacuated flask weighs 20.94 gram when filled with dry hydrogen and 29.22 gram when filled with dry chlorine at the same STP. If empty, the flask weight is 20.70 gram. Calculate the relative molar mass of the chlorine. Solution. Mass of dry hydrogen is equal to 20.94 minus 20.70 gram, which will give us 0.24 gram. Mass of dry chlorine is equal to 29.22 minus 20.70 gram, which will give us 8.52 gram. Since the two gases were measured in the same vessel, then the volumes are the same. Therefore, vapor density of fluorine is equal to mass of fluorine over mass of equal volume of hydrogen. Vapor density of fluorine is now equal to 8.52 divided by 0.24, which will give us 35.5. But relative molar mass is equal to 2 times its vapor density. Therefore,